Me
The
too.
stream is live. Let's go, baby. Mariana, take it away.
Wait, can you bring my presentation, please, on the stage?
Oh, it's Twitter, as I mentioned. Sorry.
Cool. All right, GM, everybody. It's a beautiful day to build, and it's a beautiful day to brew. I don't normally drink coffee, but even I've got my morning latte going for this. I suppose for most of the folks tuning in, it's actually afternoon at this point, but as Californians,
Yeah, here's 12 p.m. lunchtime. Wait, could you bring my presentation and our opening ceremony slides decks here? Thank you so much.
And we'll kick off.
So we are here with Jill, Whit, to start our Build and Brew Hackathon. This is our opening ceremony. My name is Mariana. I lead ecosystem growth here at Espresso. Whit, would you like to introduce a bit yourself?
Hi, I'm Whit. I lead product marketing. Happy to be here.
Awesome. And I'm Jill. I'm one of the co-founders. I lead all things go-to-market. And yeah, to date, Espresso has really focused on getting pre-existing chains that are built by usually companies that are at quite a mature stage on board and signed up to integrate with us. But we're really excited to make this developer-oriented push and start welcoming individual developers to our ecosystem. So that's what we're doing here, Mariana. I'm really excited to kick off.
Thank you so much for all the welcomings. We are very glad to have so much of you here. We have almost 200 hackers already registered, more to come as the registrations, they don't close. You have until the 31st March as the end of the submissions deadline. And I would like to share a little bit about the agenda, what we're covering today. So we're going to be talking a bit about the welcome and overview, about the hackathon, so a little bit about the tracks, the pool price, the submission guidelines, the judging criteria, a quick Q&A if anyone has any questions, some next steps. After we have Jill here present to us why composability matters and Espresso vision on it for a more connected Ethereum ecosystem. We have Ellie, our head of research, talk about how Espresso Network works. So we're going to understand a little bit more under the hood, especially because you're going to be building with it. Then we have a pleasure and nice partner coming on board, James from Across Protocol, to explain what is Open Intents Framework, what is the vision with Open Intents Framework, and the year C7683. And for the end, we're gonna just make a closing remarks, but we're gonna play the first and most important tutorial and workshop that you might need from here now on. That is how to deploy an Arbitrum Nitro rollup integrated Espresso. This will be your baseline to start with this hackathon. So we want to make sure we're going to be passing this video today with you guys. And before we move in, just understanding a bit what is the origin with this hackathon, right? So just going to explain better, but Espresso is a consensus layer purpose-built to support fast and secure cross-chain transactions. The network provides confirmations to any chain that integrates with it, regardless the stack or the settlement layer. And we came through various learnings from the past few years to now. So from a private layer 1 to the centralized sequencer to a sequencer marketplace, and now on the confirmation layer where we're focusing on with the network. We launched it last November. And after the first various interactions, we have our product ready with 2 main stacks. So Arbitrum Nitro stack, Cortese. We have the first rollup live that was Rari Chain. More rollups aligned to get caffeinated soon. But with so much infra partners and researchers, we are now focusing in one big segment of player of our ecosystem community, that is the builders. So here we are with Build and Brew. This is the reason why we're making this stroll. We want you to get your hands dirty, to understand how Espresso Networks works under the hood, to get familiar with, to build like innovative products, innovative apps that can use Espresso confirmations for. And we can do this alone. And that's why I'm going to pass to Whit, and he's going to talk a bit about our partners and who is with us on this journey.
I was on mute. Hi, we are definitely, this is definitely something that is not capable to be done alone, right? Interoperability, composability certainly is not something that only, one project, one team can accomplish. So we're very proud to be able to have, name several partners. As you can see here, we have infrastructure partners like Infura and AWS, ecosystem partners like Off-Chain Labs. All hackers will be deploying Arbitrum chains as part of this hackathon. So we're grateful for their support. Interop partners, including Hyperlane, Across, OpenZeppelin, and Bootnode. So that will be, we'll have, they'll be engaging in various ways, whether it's, by providing some office hours for hackers in our Discord, giving workshops. So you'll be hearing more from them. If you can go to the next slide, Mariana. And so, a quick overview. Mariana, I think you'll be going into more detail on some of these, correct? But there's 2 tracks, caffeinating code and cracking composability. And we have 5 prize pools. There's opportunities for various skill levels, everything from following a relatively simple guide to deploying a chain and integrating with Espresso, all the way to more advanced, tracks such as actually building, cross-chain applications that are leveraging Espresso confirmations for kind of fast, trust, minimized interop. And yeah, this will be, this hackathon goes throughout the month. March 31st is the deadline for submission. You can apply and register anytime. So there's no deadline as far as that goes, as long as you have a project done and ready to be submitted by March 31st. Next slide.
Yeah, so now I'm going to take over. Just want to remind that Discord is our main communication hub. It's where you're going to find your teams. So we invite everyone to join our Discord. We're having some hackers already looking for teams there, so find your teammate. On the track side, we have 2 tracks. The first track is caffeinated code. So the core requirement for this track is you having deployed a fully functional live rollup integrated with Espresso. We're going to have this guide and this workshop that is going to explain to you how to go over all the steps to make it through. We have additional price so a mainnet deployment. For the core requirement, just testnet is enough. A live rollup running on the cloud. It can be your provider, could be AWS, could be Azure, could be like other cloud provider. We are not making any really requirement on it. But for mainnet deployment, you need to be an Arbitrum 1 and Espresso Network. And for building something new, you basically need a creative new rollup idea and submit to us a presentation, a link of a presentation. This full track totalized $50K in total price, and a little bit of the eligibility criteria and submissions is you need to send to us a Git. It's optional, the GitHub for this track, but you can send to us if you want. We need a video of you showing the Docker logs. We have a separate video just explaining submissions for you. It's all linked in Eldora Hacks in our Discord. We need to run this rollup liveness verification for the testnet parameters. So we need a create rollup transaction hash that you can find in your contracts and your block explorer. We need the IP address of your cloud server, and we need the chain ID and the namespace of the deployed rollup. So for the additional pool price on mainnet, just parameters for mainnet, and build something real, just pretty much your link, the link of a presentation or one-pager pitch deck. For the second track, let me go here, cracking composability, you are going to go beyond. You're going to build innovative cross-chain apps on these deployed rollups you did in the first track. That's going to be using Espresso confirmations for. And this here, we have things more special. That comes the open intents framework as well, and comes all the partners that are contributing with us here. So we're going to be rewarding 2, and this is for the top 5 projects. We have judging criterias. We're going to be trying to reward as much good projects as we can with the total available price. but we have two pool price here. One is the best composable apps. So any app that you can imagine building from building on top of Espresso and Arbitrum, that could be testnet or mainnet, but reading from Espresso confirmations, this is going to be rewarded. We have a whole database of ideas, from launching like a cross-chain Pokemon Go with plans of like assets in different chains, through making a borrow lending cross-chain application, to even creating like some dashboard tracking rollups in different like bridging and different like kind of analysis and metrics that you want to show to us as a composability matters. And for the open intents one is basically if you want to make an intent, a bridging, or any of like the intents applications, that's going to be using the existing open intents framework repo. So there is a hub page, there is smart contracts, SDKs, there's toolings, everything that you use that you can show to us in which part of the code you use it, you're going to be eligible for being judged on this track as well. And for the eligibility of this track, basically what you need is, as basics, having deployed the rollup before. So you're going to be building on top of this rollup. Here, multiple builds will be accepted. So you can send one project, two projects, three projects. They just need to be original ones. So we need and we do value the originality factor here. And for the open intents one, just sharing with us in which part of the code did you use the open intents framework, GitHub repo. So when you're submitting in Dora Hacks, what we need to see from you is your GitHub link. So we do need this GitHub repo. We need a video demo of the application, the presentation that you're showing to us. We still need the rollup liveness verification because, again, this is your requirement. And for the additional pool price on the open intents, just share with us, are you using open intents toolings? Yes, no, and where? And all of this you can just share with us in the details page on your submission. And now I go over to Whit for the judging criteria, and after we kickstart our keynotes.
Hi, yeah, judges. We have several judges from several of our partners that will be announced at a future date. We're still putting together the judges, but the criteria will cover technical quality, originality, practical impact, and thrill factor. And so you can see there on the slide what the breakdown will be. And again, this will be for the cracking and composability track and build something real prizes. The tracks that actually have a kind of competitive factor that will be judged against. The deploying chains will be the guaranteed prize for every rollup integrated with Espresso on Decaf, and Arbitrum Sepolia will have a guaranteed prize. So again, to be clear, the judging criteria is for the more competitive tracks, for people that want to go above and beyond and building these cross-chain apps. So I think quickly we were going to provide, the next slide is some important dates, and then I'm going to hand it off to Jill. But today obviously is the kickoff date, opening ceremonies. On Thursday, we have a series of workshops. You can find more details about those as far as an agenda and schedule goes on Thursday. Again, this goes throughout the month of March, so and hackers can join anytime, and as long as they submit their project by March 31st, that's all good. Pitch day will be on April 7th, and then winners announced on April 10th. And with that, I'm going to hand it off to Jill, who's going to talk a little bit more about why we're doing this, why composability matters, and how you all could be part of making Ethereum composable again.
Awesome. Thanks for kicking us off, Mariana and Whit. Let me just pull my slides up here. Are you guys able to see my screen? Excellent. Whit, I think maybe you're pulling me up. There we go. Amazing. Great. So again, my name is Jill Gunter. I'm one of the co-founders here at Espresso. And today I want to introduce a little bit about the motivations behind Espresso, why I think it's one of the most important things to be working on in crypto right now. And I want to welcome all of the new developers to our community as you set out and tackle your first mission of building chains and connecting them to each other. So this is a catchphrase that we sort of developed internally over the last couple of years as we've been working on Espresso, which is an infinite garden has no walls. So you might have heard Ethereum referred to as an infinite garden. And I actually often hear that name or that moniker criticized. I don't really know what it means to call Ethereum an infinite garden. But today I want to talk a little bit about what that means to me, how it compares to traditional finance or Web 2 or the things that Web 3 is trying to build solutions for. I want to talk a little bit about the walled gardens that we know from those tech ecosystems and financial ecosystems, and the alternative that we've built and are creating and maintaining inside of Ethereum and how Espresso fits into that. So a walled garden, this is a phrase that's often used to refer to a closed ecosystem, whether that's in tech or in finance. Again, a closed ecosystem controlled by a single entity. And what do we get when a single entity controls an ecosystem? Well, that entity, that actor, can impose restrictions on who can contribute to the ecosystem, how much people can earn in that ecosystem, and even what can get built and who can access it. So you might have at one point tried to open a bank account in another country, and you might have found that you had to go through all kinds of headaches and steps to try to open that bank account. Maybe even in your own country, you found this. You have to bring in proof of where the funds came from. You have to bring in proof of residency, all of these requirements just to open a bank account. And this results in a huge portion of the population, even where I'm from in the United States, but across the world, who just doesn't have a bank account because there's all of these pain points and challenges associated with opening a bank account. This is an example of a walled garden. If you've ever built an app that you've tried to get listed in the Google Play Store or in the Apple App Store, you've also experienced a walled garden. Both of those, Google Play Store and Apple App Store, are these ecosystems controlled by Google and Apple respectively. And they get to determine what can get built, who can be shared with, and who can access the apps in those ecosystems. If you live in a country or have ever traveled to a country that has strict capital controls in place, so this means that they control who brings money in and out of the country, this is another example of this. There are all of these examples of the ways in which walled gardens exist everywhere around us today. And to me, this is really what building on Ethereum is about. It's about creating an alternative to all of these walled gardens, all of these silos that we have to endure today in our digital lives. Ethereum, to me, is an ecosystem where anyone can contribute to it, anything can be built in it, and everyone has access to it. And that is revolutionary. That is a really big deal. And I think that it's the most important thing that Ethereum gives us. And I think that we have to work to make sure that Ethereum can keep offering that to its developers and users. To contrast with what we were just talking about, on Ethereum, anyone can come and spin up a wallet. If there are pre-existing applications, whether it's wallet apps or decentralized exchanges or bridges, obviously we're working with many bridge protocols on this project, anyone can come in and just start building off of what already exists. They don't have to ask permission from anyone. And again, I think that that is a really big deal and an idea worth defending. So I would say this. I would say that Ethereum is actually the single best tool for innovation and creativity that humanity has today, because it's permissionless, it's composable, and it's unstoppable. And I think that these three words, and I'll talk a little bit more about each one, I think that these are the three superpowers that building on Ethereum and building on blockchains give you. So let's start with this word permissionless. To me, this means that anyone can contribute, anyone can build, everyone can use it. You don't have to ask permission. You don't have to go to a bank and fill out a ton of paperwork to start using Ethereum. You don't have to ask permission from Google to start building on Ethereum. You can just get started. This is a huge part of the beauty of what we're building here. And there's a million examples of this, right? We've seen whole countries run fundraisers on Ethereum with immediate global reach. This fundraiser run by Ukraine a couple of years ago, this ended up raising $225 million. And regardless of your politics, that's a powerful thing. That's a big deal. We've also seen Ethereum support funding to defend people whose own states are attacking them because it's permissionless. And so this, for example, this is a donation website where you can donate directly to people in Iran, even though there are sanctions and all of these controls in place for traditional financial rails, you can donate Ethereum directly. Ethereum is also a composable environment. So this is the second word I mentioned, right? It's an open ecosystem where anything can be built and everything is compatible. So you don't have to ask permission to start using the APIs of an application that exists on Ethereum. You can just get started building. And this is a really cool example of this. This was actually, she's since de-anonymized herself, but this was posted by an Espresso engineer. This is something that she built using Farcaster, which is a decentralized social network on Ethereum. She also used an app called Anoncast, which is a way to post anonymously to this decentralized social network. And she used a bounty application that also lives on Ethereum. And she said that, she would pay a reward to anyone who could de-anonymize her using the hash below. And I think that this, again, is a really cool example of the way that you can assemble building blocks together to make them composable on Ethereum. We also get applications like decentralized stable coins that are pegged to the US dollar that can be backed by any on-chain asset. All of these things are examples of composability on Ethereum. And the last thing I mentioned is that they're unstoppable. And so what does that mean? That means that we can get tools that no government, no entity can shut down. And that's a really powerful thing. So it's given us tools like Freedom Tool by Rarimo, which allows for anonymous referendums to be run that are verifiable. So you can scan your passport and show that you're in, you live in that country, that you're a member of the population, but you can vote and show, what your preference is for the political parties and individuals in power. And similarly on currencies, this is kind of the original use case of Ethereum and of crypto, is to be able to exit your home currency if that's what you want to do. And these are all parts of the unstoppable qualities of Ethereum. And decentralization is the thing that powers Ethereum. It's what makes it permissionless, composable, and unstoppable. Decentralization is the heart of what makes Ethereum a worthwhile and powerful project. But decentralization is extremely hard to achieve, and it's extremely hard to maintain. It demands trade-offs in terms of user experience. It demands greater complexity in the technology, and therefore it demands our constant attention to make sure that we are preserving it so that Ethereum stays all of those qualities and we preserve this infinite garden of Ethereum. And so this is something I kind of like to joke about and say that, it takes hard times to create a strong protocol, a really, truly decentralized protocol. If we just get comfortable and we don't pay attention to how decentralized the protocol is, if we enter just good times and there's no need to really focus on decentralization, then we'll end up with really weak protocols and a much weaker Ethereum that's not actually unstoppable in the way that we want it to be. And so it's really important that we pay attention to this always, and we make sure that we're building a strong protocol. And that's what we're doing at Espresso. And that's what we're inviting all of you to start to contribute to, is to build on an even stronger version of Ethereum. So at Espresso, we want to ensure that all chains that scale Ethereum, all of the rollups out there that are scaling Ethereum, can work like one unified chain and have really strong, secure underpinnings. So what I want to talk about is the way that rollups are built, and specifically their sequencers. And so many of you might be familiar with this, but rollups are the chains, again, that are scaling Ethereum. You've probably heard of many of them. Arbitrum 1 is the biggest Ethereum rollup by total value locked in it. There are many others like Base and Optimism and ZK Sync. And all of these chains, they have this component called a sequencer. And today, almost every single chain that runs on Ethereum runs a centralized sequencer component. And again, that's maybe okay, but really what is Ethereum about? It's about decentralization. So we need to talk about this, right? They run these centralized sequencer components, and that creates some dynamics that maybe we don't necessarily want as part of Ethereum. So centralized servers, right? They can maybe censor you. They can do things that, you might not have opted into. They can make you ask permission. Centralized servers, they might introduce, again, some of these walled garden dynamics. But there are ways that we can fight against this. There are ways that we can prevent this. And so this is an example of this, right? If a centralized sequencer censors you, then good news, as long as you're using one of the top L2s that has a working escape hatch, it's called, that is quite mature, and you can see all of this on this website called L2B, then you'll be able to get your funds out. You won't be able to be censored indefinitely. You might have to wait a little bit of time. You might have to pay a little bit of money to get your transaction through and to get your funds out, but the sequencer won't be able to censor you forever. But this is an example, right, of why we care about centralized servers, centralized sequencers in this place, and what they can do. So I want to emphasize, there's nothing wrong with using a centralized sequencer if you have a way to force transactions through. This is the escape hatch that I just mentioned, except for the fact that we rely on these centralized sequencers for composability, for the ability to connect chains with each other. And so today, if you use almost any bridging protocol, then you're relying on the word of this one centralized server to get your funds across. And you can see how that's a problem, right? Because that server could pull the rug on you. They could change what they said. They could walk back on their promise, because that's what any centralized server can do. And we really care about this because we care about connecting different chains. Composability is one of the key traits that we're trying to defend, right? And I think that this is true. I think that we can't live with a fragmented Ethereum. It will lose against competitors. So we really care about connecting chains on the platform. Again, today, sequencers provide a key component of interoperability, and we call these centralized pre-confirmations. These are the promises that I'm referring to that pretty much every bridge protocol is built upon today. So if you've ever used an L2, if you've ever used a bridge protocol or messaging protocol like a Cross or Hyperlane or Layer 0, you've used a centralized pre-confirmation, but you might not have even known it. Because again, almost every interop protocol today depends on a centralized pre-confirmation from the sequencer. And so you can see how this kind of cartoon starts to look true, which is that all of the cross-chain composability on Ethereum is built on this one weak leg that we need to make sure is strengthened. Because if we live in a world of many chains and we have many transactions happening across all of these chains, and they all rely on these centralized components, then we have this new threat to the Ethereum that we know and love that has emerged. We have this threat that the chain sequencers will be compromised or run by a malicious actor in the first place. And we see centralized infra getting hacked all the time. Wherever there is money to be made from a hack happening, they will happen. And centralized sequencers are no different. And so we really need to pay attention to this. And again, that's what we're doing at Espresso. It's a way to secure a chain better. It's a way to connect different chains to each other. And this is what that looks like. So we can have multiple L2s, I call them here, but multiple chains working together that are all posting to the Espresso network as one single confirmation layer that gives a very fast commitment to what the transactions will be that each chain is posting, much faster than Ethereum itself can provide. The Espresso network works on the order of a few seconds, whereas the Ethereum L1, you might have to wait for up to 15 minutes, and no user is going to do that. And this is what Espresso provides, is a secure confirmation layer that works quickly enough for everyone to use and is sound enough for everyone to trust. And so what you'll be working on specifically is deploying Arbitrum Nitro orbit chains on Espresso. This is the first integration that we've built. We'll have more coming soon. Espresso has been running on a permissioned mainnet since November. And very soon in April, the Espresso Foundation will be facilitating the upgrade of the testnet to proof of stake to make it even more secure and fully decentralized. And we can't wait for that big milestone. Espresso and any confirmation layer really is the key to composability. And secured sequencers are what is going to make Ethereum unstoppable. And I really think that we have to defend Ethereum as an infinite garden, as the home to permissionless, composable, and unstoppable applications. And that's what you will all be building. So thank you so much. I'm so excited to get to know so many of you throughout this process of building and brewing together. And welcome to the Espresso ecosystem.
Awesome. Thank you so much, Jill. For the next portion of this event, we're going to have Ellie join us. Ellie. Hi, Ellie.
Hey.
Ellie's head of R&D at Espresso Systems, and she's going to be giving us a little tutorial on how the Espresso network works. So if you, Ellie, want to share your screen? Boom, there it is. Cool. All right, Jill, I'm going to remove us from screen and let Ellie take it away.
All right, so this diagram is very similar to the one that Jill just showed, but I'm going to kind of go into more depth about each one of these pieces. So the transaction lifecycle of something that of a rollup that uses the Espresso network is as follows. So the user submits their transaction just like normal to the rollup's sequencer. And this is exactly the same as it is today. The sequencer then sends that to the Espresso network for confirmation. And then once the Espresso network confirms that, a validator or a full node or someone reading from an RPC can then use that to do something off chain or to do something on another chain. So let's dive a little bit into some more detail. So the Espresso confirmation layer is a consensus protocol. It specifically runs hotshot consensus, which is a BFT consensus algorithm. For the most part, it's fairly similar to a lot of other BFT algorithms out there with a few optimizations. And the way that the transactions are spaced in these different rollups, so is that each rollup has what's called a namespace. And transactions are submitted to this namespace. This namespace is basically an ID that ties one rollup with, its spot on Espresso. So when transactions are submitted, the sequencer specifies the namespace that they're in, and then Espresso confirms them. Espresso does not do any sort of execution or validation on these messages at all. It just confirms that they're there. So the next part is the validator. That would be reading from the Espresso Network. So in the hackathon, this is what the validator here would be referred to as our caffeinated node. That's what we're calling it. And it's just a full node that runs the state transition function of the rollup and then can output, the new state. So yeah, this validator will have a regular, just Ethereum RPC, just like any other rollup would have to connect to. And you can then use that to build your applications on top. So the key part here is that the Espresso Network confirms things. So you need both the confirmation, and then you need this full node to figure out what the execution is and what the new state is. So in this diagram, it shows two different rollups. And so I'm going to walk through how maybe like a cross-chain composable experience would be. So the Espresso Network by itself doesn't necessarily transfer data between one rollup to the other. So rollup's data is always on Espresso, but someone needs to take that and read it and maybe submit a transaction to another chain. They need to decide what to do with the confirmation on Espresso. So this is where you could have a couple of options of things to potentially implement. And one of them, a simple one, would be a relayer. And so this relayer would read from the RPC of the caffeinated node, and then it would use that data to create some composable transaction and then submit it to the sequencer of the other rollup. So this is one way to do it. A couple of extensions you could make on here are potentially making it more secure, not making it just a multi-sig, etc. But this is kind of the overall structure of how it could work. The other thing that you could do is take some real world action. So once you read from an Espresso, the Espresso caffeinated node, you can use that to have a lot of confidence in taking some real world action, like giving someone like a physical asset in the real world. And so that's another use case you could use it for. But back to the main diagram. So yeah, the caffeinated node is part of what you will stand up. And the sequencer and the rest of that are just part of the regular Arbitrum Nitro stack. And oh, yes, and one thing is, so the validator, when you're reading from the RPC of this validator / caffeinated node, it will give you things that are confirmed by Espresso. So this RPC only serves data that has been confirmed by Espresso. So you don't need to necessarily worry about checking a certificate or anything like that. Although, maybe that's an extra thing you could do. Yeah, so with that, I think that's the kind of the rough architecture of everything. This diagram doesn't include the settlement layer. The settlement happens just the same as it does in any rollup. So in the case of Arbitrum Nitro L3s, this L3A and L3B would still settle to Arbitrum 1 whenever they want. And this usually is going to happen way after the Espresso confirmation. In a lot of mainnet rollups today that are Nitro chains, they only settle maybe once every 4 to 6 hours. But yeah, so the settlement is exactly the same. But the thing is that you can use Espresso instead of waiting for this really long time for this settlement. And all right, so I think with that, that is the architecture of Espresso and how it works.
Awesome. Thank you so much, Ellie. We are now going to have James from Across come up on stage, and we are going to benefit from him walking us through the open intents framework. So James, if you welcome, first off. Thanks so much for making the time to come here. Are you able to share your screen so I can put it up on stage?
I'll give it my best shot. And thank you so much, Whit, for having me here Jill, Ellie. It's great to hear what I've heard so far. It's been awesome. I think
Cool.
did that work?
It did.
Sweet.
You see it?
Yep.
All
Ready
right.
to go.
Cool. I'm going to
Awesome.
step off and hand it over to you.
Perfect.
And yeah, thank you so much again for coming.
I really appreciate it. Cool. All right. Firstly, everyone, thank you to Espresso Systems so much for having us here. It's always great to speak at these types of events because this is where building happens. To play off of what Jill was mentioning earlier in her talk, I think one of everyone's big goals in Ethereum right now is this notion of unification, either through promoting decentralized sequencing to something a bit higher or a bit more downstream in the stack for interoperability. And so what I'd like to talk today on is this notion of unifying Ethereum through what we and the broader interoperability groups consider intents, and to also talk about this new framework that was pioneered, this standard called ERC 7683. So before we get into this notion of what and how we unify Ethereum, I think we can take a step back, get in our time machine, and go to 4 years ago, where we had a different problem with EVM, and that problem was scaling. So if we look at November 2020, if we look at these numbers, we see that Ethereum at that point had a 15 transaction per second bandwidth, and a single swap from Uniswap was greater than $50, 50 US dollars. And a solution that rose to champion this issue of scalability came from a rollup centric Ethereum. So in October 2020, this notion of rollups came to be on the public stage of EVM, and that solution worked at scaling Ethereum. If we look at the numbers, we can see that in 2020, October 2nd, when this notion of a rollup centric future was announced, by 2021, the following January, we saw that Optimism became live. And then in quick succession, in August, we saw that Arbitrum removed its whitelist, becoming the first publicly open universal rollup, optimistic rollup. And then fast forward to March, we saw that ZK rollup through ZK Sig Era was one of the first ZK rollups with universal solidity support. And all the way to March 2024, where we have proto dank sharding. So we get our world of blobs. And all of that together, through those 4 years of iterating, we moved from 15 transactions per second all the way to 336 as of November 2024. That's 26 times on our speed or on our bandwidth, which most consider that we've scaled Ethereum, which is awesome. But as with all good problems to have, we have a new problem. And that problem is not necessarily scaling, but it's that Ethereum, EVM, the ecosystem as a whole is now fragmented. So let's hop back in our time machine and we'll go back to where Ethereum was back in the day. We have one set of assets. We have one real chain that we care about. We know that if we have assets in our wallet, that those assets are all that we have, basically. But now to 2025, almost 2024, 2025, we now have a lot more chains. And with those chains, we have assets in more places than just mainnet. And for our UX, we have a lot of network switching. And in general, those assets on those chains that we need to switch to, they're all scattered. And what that leaves us with in a TLDR fashion is a mess. So that's where we are now. We've got our solution to scale Ethereum in a really elegant way, this notion of these rollups. But what we've been left with is now liquidity fragmentation. So what we'd like to do, what we've been doing for the last 4 years at Across Protocol, and what the greater at large organizations that promote intents aim to do, is this next phase of unifying Ethereum. This idea that all of these L2s, these orbits, these super chains, they all exist and commingle and have interoperability in a way that doesn't necessarily feel like you're dealing with 15, 100, 1,000 L2s. It's all one big ecosystem. And there's a few set of components that we can look at a high granular level about what this type of unification could look like. You can talk about having a better app, a better wallet user experience. We can talk in terms of account abstraction with 7702 or 4337. But what we do and what we look at every day is this notion of fast bridging, this other core pillar of the unification of Ethereum. And our core thesis is that and others that support this intent-based interoperable ethos, is that to unify Ethereum is to have interoperability, this communication between these blockchains, either value or message or information, is that interop needs to be fast. And more to that, it needs to be 2 seconds fast. And where did I come up with this 2 seconds? Well, if we go to Web 2 land, where we don't always live, because in native Web 3, we scoff at it sometimes. But it's good to see that the metrics that these Web 2 data analytics providers, what they talk about is that if we're talking mobile website design, 53% of visitors abandon the site if a site takes longer than 2 seconds to load. This is what the next generation of onboarded users have come to expect from their web experience. And given that, having your money in flight for more than 2 seconds could be stressful. So what our thesis is that intents are the only viable mechanism to deliver this 2-second value transfer, this interop experience, within the context of Web3, through interop, like with bridging and value transfer. So let's first talk about what interop is. And to do that, we can look at this notion of what traditional bridge flow is. So in a traditional bridge, to start, a user deposits funds on chain A. So let's take Arbitrum to base. So they put their money in Arbitrum, and then they wait for finality on chain A, because the bridge needs to confirm that funds have been in bridge A or chain A and have not been reorged. So it waits for finality, and then it sends funds from Arbitrum to base. And then once it gets to base, we're able to release those funds. And this is an elegant solution in itself. But one of the hallmark pitfalls that we found with traditional bridging is this notion that it's slow, right? Even the notion of waiting for finality is slow. So you get these multiple minute bridges from one in unidirection routes, and then you get these long multi-day lockups, what feels like, in these slower routes. And what we are positing is that the intents flow is more user-centric. So let's talk about what that looks like in terms of bridging. So to start, we have this same notion, a bridge from Arbitrum to base. And what we would like to do is get funds from A to B in 2 seconds. So first, in a similar way, a user puts money on Arbitrum and it puts it into the escrow on chain A. In that moment, a network of intent-based solvers, these systems, these solvers that look and wait for these escrow services to receive funds so that they can solve that bridge route on the destination chain. They receive this information, it's broadcast to them. And one solver, the most competitive, the most efficient solver, is able to beat out the other solvers and complete that fill for that user to get as fast as possible. We see that that UX is actually consistently improved through that competition. And so what we have is a fill in 2 seconds. And we see this in real time every day on the across, in our across metrics. But what we actually have was a external actor taking a risk. They filled the user, so they need to now be made whole. So in a secondary act, the system must settle, it must verify a fill and release those funds to the solver. So the solver needs to be made whole because they just used their funds to fulfill the intent of one of the users in this system. And so what you see is a median fill time of 3 seconds, and you see this really low cost endeavor to accomplish this. And this metric, this volume metric, is actually out of date because across reached 20 billion in recent times. So what we see is razor fast fill times, this competitive pricing where relays are doing their best to compete within each other, which provides this holistic benefit to the end user. And you have this large amount of volume that essentially what we consider proves the product market fit of this intent system being a solution to the fragmentation problem in Ethereum. And so just like there's a common form for tokens, we've all come to a conclusion that the best way to talk about intents is actually to standardize intents. And so that's where we get to ERC 7683. In a world where many companies and protocols and projects, they build in a way where there's a friend or foe, we think that the idea of working out in the open in a radically decentralized, optimistic way, that we're all trying to do what's best for the end user, that's the hallmark. That's our ERC 7683. This notion that we have this concept of it's a standard that can be used by multiple different settlement systems, these across like products, to the benefit of the end user. So let's talk about 7683. 7683 is an order ticket, right? So it is a standard way for a user to say that they want to move funds or value or information from A to B, given a settlement system, which could be across, it could be another platform, an origin, a destination, and various things like arbitrary message execution. And when a user inputs their intent, this intention to do something, these underlying solvers, they handle it on the user's behalf. They solve the intent of the user. And what you get is one-click bridges plus absence. So a user bridges an ETH and they swap it for a frog token. And that all happens in this seamless one-off way, this one-click action. And you can do things like bridging ETH and buying an NFT, or bridging an ETH and depositing into an Aave vault. Or you could even just bridge an ETH and execute any 7702 message. So you get this arbitrary execution. And what you see is this settlement system, it's modular. It supports native interop. It supports Polygon Ag Layer. It supports RIP 7755. It supports any of the settlement systems that I just spoke about, including many more. And the reason we have this standard as a helpful system is because it's a single common format that anyone can build off of to do cross-chain. When you only need one integration, one format, and you can hook into any other settlement. And for solvers, if you know the standard, you can build a common format for your solvers so you can provide liquidity to all of these settlement systems. And what you get is a world where we're all working together, benefiting Ethereum, reducing liquidity fragmentation. And in closing, what's next? So what's next for ERC 7683? Well, it has broad support. All the major L2 ecosystems support it. 25 other projects have also supported the standard. But as we spoke about in that beginning, those core pillars of unifying Ethereum, reducing liquidity defragmentation, we also now have to work toward building these better dApps with better UX patterns, which ERC 7683 helps us with because it gives us that common format. We don't have to do all of the hard work to reinvent the wheel. And we get full integration with EIP 7702. The Petra hard fork will make smart contracts prolific, ubiquitous, and that will all allow for seamless chain abstraction everywhere, unifying Ethereum, and that interop is provided with ERC 7683. So that is, I really appreciate y'all taking the time. This is my Twitter. I think Twitter's down right now, but happy to answer any questions. But yeah, thank you so much.
Thank you so much, James. Yes, can confirm. Twitter's down. This live stream was
supposed
to be also live streamed on our
my
Twitter
heart.
account.
Yeah,
it's, hasn't been working.
Nice.
But thank you so much. Mariana, are you there? Can you turn on your camera? James, are you able to just stick around just for a few seconds? Is there any if we're talking to hackers who are maybe interested in building Brew and obviously building with with Espresso and open intense framework and across, you want to open to just like brainstorming, like what's possible, like what are some ideas for projects that they might pursue, what kind of projects are necessary, like in your experience, like you come across like, oh, it would be cool if someone built X or Y. And Mariana, please jump in too. But
of course, yeah. I mean, I think the cool thing about ERC 7683 and Intense as like an interop medium is that it gives you this capacity to do arbitrary things. So like you can take a dApp, for example, that doesn't have multi-chain, and you could build an interface to make that multi-chain. So what I think are the cool integrations are like depositing into a vault or depositing to mint an NFT or swaps, cross-chain swaps. These are like really powerful things that teams are working on, that we've seen teams working on, that at Across we like to focus on ensuring that what we do is good, high quality interoperability. So that's not like these are things that like if I was able to hack and be part of Build and Brew, at least for this session, that's something that I would be interested in. This idea of the cross-chain swaps, because it's ubiquitous that we swap, and it's also now ubiquitous that we deal in cross-chain. So there's a cool notion of a nice intersection.
Yeah, I think this is also nice, James, when like the cross-chain swaps just happening under the hood, but actually the intent that is working. Example, like just putting like some borrowing some money in Aave, but then for this I'm making like under the hood some swap between like the chains or even the token that I wanted to apply, but it's just underwriting it. I have like just one question. When
Sure.
we look like this intent solver space, how would you say like is the biggest challenge right now? Is like chain adoptions, is scaling up for more like ecosystem, is like solver liquidity? What do you see like as the top three challenge or like top two?
Yeah, no, I actually gave a talk at ETH Denver on just this. So there is, so one of, at least with across our core ethos is if you user or like liquidity, shared liquidity follows user demand. And what I mean by that is that these high route chains, these like Ethereums and Base and like Unichain or Arbitrum, these chains have these deep liquidity pools because there's a ton of demand to bridge in and out of these chains. And therefore, these solvers, they focus their liquidity on them, and therefore you get a great user experience. So some of the longer tail routes, these assets that may not be as popular, these these chains that may not be as mature, what you'll see is there's less liquidity because there's less solver activity. So what we've noticed is that a great way to improve that is to promote this notion of having a standard cohesive interface on what a solver can do so they can go throughout different settlement layers. But also, if a project is looking for this decentralized approach to cross chain, basically outsourcing their cross chain, they're able to run their own relayers. So what I think is a great like solve, a value unlock that we found at Across is the fact that our relayer network is permissionless. Anyone can go in, look, make a solve, make a fill, get repaid. It's not, it's a like if it's incentivized for you to do it as a project to make your user experience better, you get a yield while you're improving user experience. It's a pretty big value unlock having permissionless relaying.
Yeah, no, you brought a very good point. Like the not most famous assets, famous chains facing the liquidity problem, and how like permissionless can make it way easier, right? And this standardization as well. Thank you so much. I don't have any other outstanding question. I don't know it if you have, but
No.
I did appreciate your session a lot. I learned a lot. Thank you so much.
I
I
appreciate
didn't
it.
have necessarily another question, but maybe like a confirmation in discussing espresso confirmations. Like I think as like obviously the big chains, I think solvers, in an intent-based system, there's obviously this finality risk they take on, right? To try to provide a good user experience, right? You're not going to wait 15 minutes, for L1 finality, and so when they're dealing with like, Arbitrum and Base, the examples you use, obviously they are, Base as a centralized sequencer and but they're big, they have the reputation, so they're trusted, right? So I don't think they necessarily calculate much risk into those types of interactions. But the smaller chains that you mentioned, like, right, if they, are wanting to be swapping and bridging assets to these smaller chains, sometimes solvers maybe these smaller chains also have this centralized sequencer. There's a little bit more maybe
Risky?
thought that goes into accepting that risk. And I think that is one area where Espresso actually is helpful because, it basically prevents from sequencer, equivocation. So, a solver, instead of trusting the smaller chain with a centralized sequencer without much reputation, if it's integrated with Espresso, that solver can trust the Espresso confirmation.
Yeah.
And I guess I'm just, just
No,
pointing that
that's
out and
very
making sure that I'm understanding that correctly.
100%. No, that's definitely a consideration when integrating onto these smaller chains. Definitely something that Yeah, I mean, depending on the TVL of the chain itself, if there's not enough TVL, like there could be an incentivization to do not awesome things, and to have a decentralized sequencer would obviously go a long way in alleviating that as like a pain point. So that's a good call. Yeah. Yeah.
Is it
Awesome.
different prices? Like, let's say we're talking with a new chain, there's some risks there. Like, would the solver want to like have a different price charge to like take on more risk on that chain? Or
I mean, so capital costs and relayer fees, which is what we'd be talking about, are something that is configurable from the context of the relayer, like at the relayer level. Across provides what we call a suggested fees endpoint. It's this system that's integrated into Jumper, into
nice.
Bungee, into like anywhere where you see the across name, they'll be using this suggested fees where you can call into the route, the specific route that you want, and you can get a suggested fee for what that deposit should be to provide like an effective high chance of being executed. But yeah, I mean, the relayer itself can choose whether or not they want to take something or not. But that's something that is more of a per relayer configuration. But that's a good call. That's a good point. So far, in any situation, on every chain we've deployed, we've had a competitive network, and because we've had a competitive network, when you're racing each other to get the fill, and when it's a first come first serve, you have to beat out your competitor, and to beat out your competitor, you have to have a faster execution speed or a lower price, and it kind of drives the user experience up and to the right, which is always really awesome to see.
Nice.
Awesome.
Nice. No, great points here. Thank you so much, James.
Thank you so much,
Of course.
James.
Amazing. Thank you all. I really appreciate it.
Thank
Cool.
you. We
Happy
hope to
building.
see you more. Happy building.
Take care.
Wait,
All right.
so let me share the last two screens before we go to the first workshop that will help builders to start with the project. Feel free to handle over from here, Whit.
Yeah. Hand it over to you, sure.
Sorry?
Did you say hand it over to you?
Yeah, no, to you. You can just take over from here. Sorry.
Let's just go over the important dates again. So today, obviously, is launch day. We have workshops on Thursday. More details about those can be found on our Discord. The hackathon goes throughout the month, and so as long as you're submitting your project by March 31st, you're good to go. Register on our Dora Hacks page. Pitch day will be April 7th, and then the winner's announced on April 10th.
Good to also point out that the pitch day is regarding the cracking composability track, as the first track is just shared pool price, and the build something real would just be like Espresso analyzing the best and most creative rollup ideas. So pitch day is merely for cracking composability. And then, as Whit mentioned, for everyone to submit by March 31st. And Whit, please, if you want to just take along the next steps for everyone to know what they could start doing.
Yeah, so join the Discord. That's where all the chat's going to be. We're going to have office hours every Friday, starting this Friday at 4 o'clock afternoon UTC, 12 o'clock noon Eastern time. And that will those will be an opportunity for builders and participants in the hackathon to get access to engineers on our team to ask questions about the hackathon. And we're also going to be we have the workshop day on March 13th, which is Thursday, which will be covering a few key technical topics, including workshops from our partners like Hyperlane And I think we will be, probably scheduling some additional type events or office hours, maybe with some specific topics also. And obviously all that information will be communicated via our Discord. You also obviously find a team on the Discord, because, this doesn't have to be a solo hackathon. Maybe, there's, you bring a certain skill and, but not have all the skills necessary to build like a cross-chain app, but you have an idea and you want to find other people to help you build that. We have a channel on the Discord where you can look for some teammates.
Yeah,
And-
just a few more topics here on the Discord. The link is on Dora Hacks. You can also find through Espresso Twitter accounts. There is a builder verification that you just need to send your Dora Hacks link. For the workshop this Thursday, we're going to have Hyperlane, boot nodes, Open Zeppelin, Espresso again. So you're going to learn like how to read from Espresso confirmations, how to build like a CI/CD pipeline of smart contracts, a little bit more on the implementation of some of the open intents frameworks and the GitHub repo. We are going to have also a cross explaining how to use their SDK and APIs. So everything that you need to as guides and toolings to get you started, you have by Thursday. But today we're going to be passing and sharing with you the first guide, the first workshop that you can learn for you to start building. That is the basic, that just explains how to deploy an Arbitrum Nitro integrated with Espresso rollup. And this video was recorded by Jean, one of our software engineers. He's going to be on the office hours. He's on the Discord as well. And yeah, we are here to help. We are happy to have all the bidders with us. And any questions that you might have, shoot us on Discord, shoot us here on YouTube. And wait, whenever you feel ready to start the video, I think happy hacking for everyone, and happy welcome to be a cross-chain pioneer.
Awesome. All right, Jean, going to start the video. Here we are. So we will have this workshop, and then this will obviously be available on our YouTube channel as well, to obviously watch at your pleasure. But here's Jean walking through the deploying a Espresso integrated Orbit chain. And yeah, take it away, Jean.
Hi, everyone. This is John. I'm a software engineer at Espresso Systems. And today I will be guiding you throughout this technical workshop that is going to help you deploying your very own Arbitrum Nitro rollup that is integrated with the Espresso Network. So just to give you a little idea, by the end of this workshop, you will have all the tools needed to deploy your fully functional Espresso Nitro integrated rollup, which will in the end allow you to be eligible for the very first track of this hackathon, which is Caffeinate and Code, the Caffeinate and Code track. And then this will also be the building stones for you to be able to build applications on top and actually benefit from being integrated with Espresso, and which will open the doors to for the second tracks and all the others of this hackathon. So just to give you an idea, this workshop, this guide, and all these steps usually take up to a few hours. So I'm not exactly going to be running everything with you, but we will be going over the guide and giving you all the tools and going over all the steps and fill in with some information you might need to be able to run everything on your own after this workshop. So what we will be going over in this workshop is, first of all, I'm going to give you a quick overview of what it is for an Arbitrum Nitro rollup to be integrated with Espresso. We'll go over some of the dependencies, deploying all the required smart contracts for your rollup to be functioning. Then we'll be actually showing how to run your rollup locally and testing it. So sending transactions to it, verifying that everything is actually quite working as you would expect. And we're gonna also, there's a section in this guide for like deploying your everything on the mainnet, because in this workshop we'll be showing how it works on Arbitrum Sepolia, and as well the Espresso Network on testnet, which is the decaf. And then we also have another section, which is quite very important, which is the cloud configuration, which will allow your rollup to be continuously running, even when, for example, your laptop is shut. So we'll be running it on a cloud EC2 instance, which actually is a requirement to be eligible for this track, right? And will also allow us to interact with it and see if everything is working up and running correctly. All right. So that being said, let's get started. So actually, this is a very self-explanatory graph that shows you kind of the overall architecture, how things work. Compared to just having an Arbitrum Nitro rollup, the main things you want to be focusing at on this graph is, first of all, this TE, which we call a trusted execution environment, in which the batch poster runs. So it's a separate, like the name says itself, like a trusted execution environment, which will be running the role and the task of the batch poster separately and sending attestations. In the case of our guide, we're actually mocking this TE component because it would take longer and more complicated to set up. But like basically what you need to keep in mind, and it will make sense in the code itself, is like we have mocked TE verifier contract to kind of omit this part of the entire architecture. And well, second of all, so basically instead of just like sending your transactions and waiting for them to be well settled on a layer 1 after quite some time, basically this is where the Espresso Network, so the confirmation layer, comes in. So transactions all through batches are actually sent to the Espresso Network, which gives you fast confirmations before your transactions are even settled on the L1. So I'm omitting quite a lot of details, but it's just to give you quite overview of how things work. All right. Well, that being said, we can get on with the guide. All right. Perfect. All right. So there's a lot of documentation for you to access in the docs. So feel free to read if anything, if you would like to go a bit more into details and get to learn a bit more about how things work. But yeah, so there's a lot of information right there for you. All right. So first of all, important. I mean, if you don't have the dependencies, you won't be able to run everything. So make sure everything is installed and properly running on your computer in order to go to the next steps. And yeah, so it's depending on everyone's computer. So go through at your own pace. All right. So the first important part is actually deploying those Nitro contracts, which are going to be the ones actually running your sequencer inbox that is going to receive the batches and all the smart contracts required to have your rollup running. So go to this repository right here, go to the branch develop, install everything. And first step we're going to ask you to do is create your environment file.env and add a private key, which is going to be the private key used to deploy the contracts. Keep in mind it's going to be approximately 0.15 ETH to deploy all the contracts. So make sure that your address is actually funded, and go get yourself an RBScan API key, which you can get here. You just need to create an account, but that shouldn't be too complicated. All right, and like I've mentioned, so basically this is the Espresso T verifier address, which is actually mocked, that just returns true. You can add it as well in the environment file. All right, perfect. Yeah, so in the repository, you have this config.template.ts that you can rename to config.ts. Let me go over it with you. Basically right here, so under scripts in config.template.ts, we have added a lot of placeholders here for the variables and addresses that you need to actually input. So amongst the important ones, so well, the chain ID, obviously, right here and right here. This is going to be the chain ID of your own rollup, so try to find something unique and different. I'm not sure exactly how to get all the existing chain IDs, but try to be creative on that one, right? Then you also have this owner address, which is going to be the owner of the rollup itself. Keep in mind as well that do not forget there's also this variable right here in the chain configuration, which is also the initial owner. So don't forget to change this one right there. And now this is done. We have the Espresso T verify address right here. And then we come to this validator and batch poster. So these two addresses can be the same for the batch posters, but they need to be different than the one in the validator's address. So right here in the guide, we've actually added some information about it. Every time some transactions are going to be made in the process of the rollup, these take approximately that amount of funds. So you can see it's a very minimal amount, but make sure that the two addresses that you provide also own a certain amount of Sepolia ETH, right? Even though the amount is minimal, this might be a blocker if they're not funded. All right, so make sure this address different than this one, and you can go on with what's next. All right, now this is all set up. You're going to be able to run the scripts that are going to deploy your own contracts. So you do not need to touch upon the scripts themselves. They've already been made for you. You just need to run this specific command, which is going to deploy this rollup creator address. So then once this is done, which shouldn't take that long, you get the deployed address right there. You add it to the environment file, and then you'll have everything set up to actually deploy all the rollup contracts right there. So through this command. Little notice if you want to deploy on mainnet, which is another section of this workshop, but like keep in mind, ARB1 would be the corresponding network on the mainnet. All right, so that being said, I don't know if I actually deploy the contracts themselves. So where are you going to deploy the create ETH rollup script? Well, you're going to get all these addresses shown to you. So keep the log terminal open. Why? Because you're going to need those addresses. Don't worry if you end up quitting or killing the terminal. Most of the addresses are shown here. There's going to be created for you with all the addresses which you've deployed. Not all of them are going to be necessary, but it's just a way for you to keep the addresses that are required from you. And so this is another way, or you just find the address of the deployment. So you can find on your specific address. And you go on the Sepolia, Arbitrum Sepolia Explorer, and you just find the transaction that actually deployed all these contracts. And here you have all the created contracts. So right now it's hard to define exactly which one is which. But if you actually go in the logs and go up to the bottom of this, here you get the addresses that you need for the next part, which is coming up, and that I'm going to go over right now. All right, perfect. So now this is done with this repository. We're going to switch on another one, which is going to be, well, actually running your chain, running your rollup. So go to this repository. You can git clone, cd into it, go to the develop branch. Okay. Now, once this is done, there are two files that we need you to get updated. Here are the required updates, just to make sure that you go over them all, but we're going to go over them as well together right now. And it should make a lot of sense. Like if you try running and you haven't modified it, then it won't necessarily, it won't work. But we've also, similarly to before, added some placeholders, so initial chain owner. The deployed add as well, which was in the logs we've seen before, and all the specific contracts that are needed for your local to be able to deploy locally your rollup with the corresponding addresses which you've just deployed. So this is just like setting up all the necessary information for the L2 chain configuration. No private key for now. Don't forget to change the chain ID. This is the parent chain ID. So in this case, Arbitrum Sepolia. I believe that if you are an Arbitrum mainnet, you just need to omit this 4. This is just 42161. And if you want to as well, don't forget to change the chain name. It would work even with this. It's not very important, but like, yeah, it's up to you. And then the second file which we're going to ask you to change is this full node.json. So first of all, your an RPC URL, depending on the RPC provider you're using, but go create yourself an API key, and whatever you're using, just upload it here and choose specifically for WebSocket instead of HTTP. Same thing here. Reflect on the chain ID of your very own rollup deployed, the one you chose. Make sure it's consistent over all the configuration files. And then here we have the staker information. So right here for the staker information, staker is basically the same as the validator. It's don't mind the name. It's basically the exact same thing. So this is going to be the private key of the address, which you've just specified here in the validators. All right. And same thing similarly with the batch poster, which you can find right here. Add the private key of the address, which you've specified right here under batch posters. All right. Very important. And another extra thing, so for the rest is fine. Here, right here, we have the hotshot URL and light client address. Considering you're deploying right now in this guide on Arbitrum Sepolia, the hotshot URL is decaf for the testnet, and the light client address is an address deployed on the testnet. But in the guide, in this deploying your rollup on mainnet, you can find the addresses you need for the T verifier. So these as well are mock addresses for well, the mainnet address, and as well the hotshot URL for the mainnet, if you wish to deploy on the mainnet. Perfect. So with this in mind, now that we've configured the chain files, this is basically a Docker YAML file that was created for you. You do not need to modify it. It is basically going to expose these ports and run your rollup locally for you to actually like send transactions to it and everything. You can go into more detail if you want, but it doesn't need to be modified. It's been already set up for you, and you just need to run it by running docker compose up in your source. I mean, in the source repository. Well, up in your repository. So I've actually done it right here, slightly before, ahead of you. Just to make sure it's properly running. So you'll get a bunch of warnings, a bunch of infos, a bunch of errors and stuff like that. I mean, when I say errors, you might get some information. I think I saw one here. Error polling, finally, we'll try. These doesn't mean that your rollup is not running properly. We've actually added here in the guide some of the warnings and things you might be finding. It's just for you to get an idea of if things are working properly, because it can be confusing when you see all those messages, logs, messages, and everything. So, for example, this first one, if you see error acting as staker, this does just mean that there's not that much activity on the rollup at the moment, meaning there are no transactions sent or whatever, right? What you will be searching for is basically this. So we're going to show you how to send transactions to the rollup to just get to that point. But until the moment you send a transaction and you get this message, it can take up to 30 minutes. It depends on the computer, on the setup, all of this. But this is actually what you're actually looking for at the end. If this is okay, it means that, well, your rollup is perfectly running smoothly. All right. So yeah, some important notes. There's a lot of information, indications throughout the guide, so feel free to look at it and take a bit more time on that, right? Okay, now that this is done, basically our rollup will be on this port, like I've said, 8547, specified in a Docker file, right? So these are all some calls that you can make to the rollup. So checking, for example, the latest confirm node, or bridging funds to the rollup to be able to send transactions. So we're actually giving you step by step. So bridging funds, which can take up to 15 minutes. Here, for example, your inbox contract address, you can find it in the configurations. Your rollup proxy address, same thing. It was shown in the logs. So feel free, just update the addresses like needed. And once you've sent funds, just check by verifying your balance, and then you're able to do transactions, check the recipient balance. This is just like a few steps for you to follow. In our case, I've already sent funds because didn't want to wait 15 minutes, and I've already been testing out and trying out the rollup. So now that you see it's actually up and running, fetching Merkle Ruta Hotshot, it's actually running like properly. And if I go and cast the balance to this network, which is 8547, to the rollup, you'll see that there is an active balance. If you actually don't have it running and you do the call, well, obviously it's not going to work because the port won't be exposed. So it's just a good way to see that your rollup is actually running. All right. And so instead of going through all these steps together, I'm going to show you this this transaction flow generator. So this is like a small script that we've actually included in the same repository. So you just need to navigate to this subfolder, which you're going to see together. And basically what this does, it just sends transactions every, for example, 10 seconds. I'm not going to show you the exact file right here because there's my private key. And I wouldn't want that. But if we go here together and go to this index.mgs, basically what it does, as simple as it is, you just input the address of the rollup that has your funds that you just bridged to, the recipient address, and then you specify the JSON RPC provider. Quick thing is when later on it will be in the cloud configuration and deployed on the cloud, it won't be this specific address, but it would be the IPv4 address of the EC2 instance you've just deployed. But we'll go over it together very quickly after that. All right, perfect. So let's come back to the guide. Awesome. So this is just a transaction flow generator. And in this hotshot query tool, there's a branch called read hotshot, which actually listens to the Espresso network and listens when transactions are actually received for a specific namespace and for a specific chain ID. Namespace, chain ID, same thing, just two different names. It might be confusing, but it's the exact same thing. All right. So, okay, all right. We know that the rollup is up and running. Perfect. We're going to run this transaction generator. All right. And we're going to see. All right. This means the transaction has been sent, right? So if you go and check in the Docker, in the rollup running, right here, you see, look, enqueuing pending transaction, enqueued pending transaction to Espresso was successful. All right, we'll just stop this because we don't want to be getting all my funds, even though the value is very small. We just don't want to overload it too much. Oh, actually, we're going to keep it running. Why? You'll see. All right, so we see it running right now. Then we're going to go in this repository, which is the small read hotshot. Wait, let me zoom a bit because I don't think you can see. This is just basically a little script that listens to hotshot. So it's the hotshot URL, so it's on decaf and the chain ID, right? And so if I go run the script, which is in the Go, it just gives you like some details, blah blah blah. Then transactions come every 10 seconds, so it should see you should see one in a second. But if you wait a bit, is it running? Okay, all right, perfect. Now, as you can see, let's stop this right now. Perfect. Awesome. Okay, now that we've seen that, like we see right here, we have this this transaction right here, which includes, so this is the response, hotshot namespace transactions with the transaction itself. Perfect. And it gives us the latest block height right here. So we're going to copy this block height that includes the transaction, right? Basically, this just does small HTTP calls to the query API from Espresso testnet. And so if you go into the tool, Awesome. Yeah, actually, it's in the tool itself right here in the main.go. Yeah, it does calls to this API. So like you see before, it was like this, like v0/availability block. We give the block number, which is just specified, and the namespace, which is the chain ID. Let me show it right here. So if I actually go here, I'm not sure you can see, but if I include the just block number, which you've just seen, perfect. We actually see the same transaction that was executed and that was registered on Hotshot. In the second guide, we'll go a bit more about how to parse all this information, because now it's just like some random bytes and it can be confusing, but this is just to be listening to Hotshot, seeing that your transactions are properly submitted to the rollup and first to the Espresso network. All right. So there's a lot of things coming up together. So it might be a bit confusing, but keep in mind, so testing out the transaction flow generator and the Hotshot query tool to be listening to the transactions being sent to the Espresso network. All right. I'm not sure this will be, we'll have had enough time. Actually, we're going to stop generating transactions and listen to right here. So basically, as soon as transactions are sent, the rollup is going to try to validate the batch. So if you see a lot of these false, it's fine. It's just repeating until like it actually validates properly the batch. And well, actually, we can keep it running a bit in the background and see if the computer and the rollup was fast enough to finalize the transaction by the end of the workshop. Awesome. Great. All right. So here, like I've said, you've got this section for deploying on your rollup on the mainnet. So all the tweaks and changes you need to do. The one which we haven't mentioned so far is in the full.json. Don't forget to replace with this public node RPC URL that links to the mainnet. All right. Now this is all done. You've seen how to test it out, how to try it out. Perfect. That's awesome. Now, for this hackathon and the requirements, we want you to be running it on a cloud and on an EC2 instance, like I mentioned before. All right. So follow these steps. It's pretty straightforward. You just need an AWS account. You might need to be able to input your credit card. So follow all these steps with a specific type of instance you want. Everything is pretty straightforward here in the image, so nothing too crazy. Just make sure you select a key pair, an SSH key pair. You can create a new one if you want for this specific case. In the preparing environment section, we're telling you how to streamline the process easier. So moving your key to the SSH folder to be able to, for example, here, do these calls from the SSH folder. Just ping your host being either your IPv4, like right here, the IP address of the EC2 instance, or the public DNS, just to make sure that it's running properly. I've had some times where being on the wrong network, it was connection refused. So you might want to use, like, for example, mobile data. Everything should be self-contained. Then once this is done, we need you to create in your EC2 instance the config folder, which just the required files that were needed. So like there was the Docker file, the config file. So all the configuration files needed to be able to run the Docker file inside your EC2 instance. There's also some configurations here to be able to install properly Docker. Just follow these steps. It should be self-contained. You should have all the information you need. Awesome. So now connect to your EC2 instance, do the exact same thing. Docker compose up. If you come across this error, which I've myself been with permission denied, make sure you create the necessary permissions. And that's it. Once you've done with this and that your rollup is running the exact same way it is running that it was running right here locally on the Docker, well, it should be Perfect. You should be good to go. Sorry. And yeah, and so now if you want to test it out, instead of having, like I've said, it was 127.0.0, just for each of the calls, just right here, put the host, so IPv4 or DNS name. So it's basically right here in all these calls. So I was in testing the chain, instead of having yeah, just add the proper DNS address or IPv4. I mean DNS name or IPv4 address. All right, now if we check this, did I have time to be validated? It's just continuously waiting to be accepted. Yeah, so a lot of logs, but which means that everything is working perfectly fine. Just need to wait a bit, and that's it. Perfect. Well. Thank you for bearing with me throughout this entire workshop. I hope it will give you the sufficient tools and indications for you to get started. Remember, you can always reach out to us if anything, raise issues, reach out on either Discord or other channels. So yeah, thank you, and happy hacking to everyone. Good luck. Bye-bye.
Awesome. Thank you so much, Jean. And with that, we are going to wrap up this live stream. Again, we are super excited to get started and have all you builders out there working and working on your apps and building on Espresso, as well as with some of the tech from our other partners like Hyperlane, Across, and Bootnode, OpenZeppelin, all of which are our partners, and obviously with Arbitrum and Off-Chain Labs, given that you'll be working with Orbit rollups. And again, just another call to go ahead and join the Discord, and also go to DoroHacks. The URL is there, and register for the hackathon. Yeah. And with that, I'm going to wrap up. Thank you so much. This is going to be fun.